Hello everyone. Let's talk about conditions for domain of functions. We have seen in our previous classes that there are certain conditions that must be considered when we are talking about domain of functions. These conditions are dependent on the type of function you have. We have a type of function where we just have the numerator being divided by the denominator. And we also have a type of function that has roots. We have a fraction that is being divided by roots, and we also have fraction that will have roots at the numerator. So these different type of functions, these different settings, we need different approach when you are talking about domain of functions. In this case, the condition to get the domain of this function is that we set the denominator not equal to 0. The condition to get the domain of this function is that we have to set the denominator. In the first function, we'll have the denominator to be x squared plus 5x plus 6. And in this second function, we have the denominator to be x squared plus 3. So we need to set the denominators not equal to 0 in order for us to obtain the domain of each of these functions. So for the first function, we have from the denominator we have x squared plus 5x plus 6 not equal to 0. So when we factorize this, we have x plus 3, x plus 2 not equal to 0. So when we separate these two factors, we have that x plus 3 is not equal to 0. We have x plus 2 should not be equal to 0. So what this means is that x should not be equal to negative 3, and that x should not be equal to negative 2. That's after subtracting negative 3 from both sides here and negative 2 from both sides here. Right, so we need to represent our domain in terms of set notation. So if we must write in set notation, we have the domain. I want you to have in mind that this is just basically x should not be equal to negative 3 and x should not be equal to negative 2. So x can be any number at all, ranging from negative infinity to positive infinity, but not equal to negative 3 and negative 2. So if we when we write this in terms of set notation, we have that x should be any number from negative infinity up until negative 3, but not including negative 3, combined with, or you call it union, every number from negative 3 but not including negative 3 up until negative 2 but not including negative 2, because of space, union every number from negative 2 to positive infinity, not including negative 2. So this is the domain of this function. Then let's test for the domain of the second function, where we have 1 over x squared plus 3. So we need to set the denominator also not equal to 3. Not equal to 0 rather. So we have x squared in this case plus 3 should not be equal to 0. So we will subtract 3 from both sides. We have x squared should not be equal to negative 3. And in this case, if you look at this, you see that there is no condition where x squared will be equal to negative 3. So basically, the domain of this function will be all real numbers. The domain of this function will be all real numbers, or you can write it in form of set notation to be everything from negative infinity up to positive infinity. That would be the domain of this function. So let's look into the domain of functions where we have the roots. we have root x plus 1 for this first function, and the condition is that we set everything under the root greater or equal to 0. We set everything under this root greater or equal to 0, and we have for the first function x plus 1 should be greater or equal to 0. So when we subtract 1 from both sides, we have that x should be greater or equal to negative 1. So if we want to write the domain of this function, we know that x can also be equal to negative 1, or it can be greater than negative 1. So we are going to use what we call the square bracket to show that to show that negative 1 is included in the domain of this function. So we use what we call the square bracket up till positive infinity, right? So what we have here as the domain of this function is that from what we got here, that x should be greater or equal to negative 1, right? So we use the square bracket to represent that x can actually be equal to negative 1, unlike what we have here where x is not equal to negative 3 or equal to negative 2, and that's why we have the parenthesis, or you can call it the normal bracket, right? So for the second function, we have f of x equal to root x squared plus 5x plus 6. So we are going to set everything under this root greater or equal to 0. So we have that x squared plus 5x plus 6 should be greater or equal to 0. Now when we apply inequality, we have x to be less or equal to negative 3 union x to be greater or equal to negative 2. Then if you are having problem with inequality, please check out my videos, my video on inequality, so that you will get cleared. So then we have to rewrite this in terms of set notation. What this is telling us is that x can actually be less or equal to negative 3. X can actually be less or equal to negative 3, and also x can also be greater or equal to negative 2. So we have everything from negative infinity up until negative 3, including negative 3. That's the work of this square bracket, including negative 3 union everything from negative 2, including negative 2, up until positive infinity. So this is the domain of this function, right? So let's go to the next condition. When we have fractions that are being divided by roots, by square roots, we need to set everything under the root greater than 0. We don't need to have a 0 under this root. So the domain will not be defined, and we also do not want to have a negative number also. So it will be on the complex side. So we have x plus 1 should be greater than 0. So when you subtract 1 from both sides, we have x to be greater than negative 1. So if we represent this in set notation, we have the domain of this function will be equal to, since x is greater than negative 1, everything from negative 1 but not including negative 1 up to positive infinity. So this is the domain of this function, right? So let's talk about the last one on our list, where we have the roots on the numerator, as the numerator, and they're being divided by x squared minus 4. So we have two conditions for this, right? We need to set the denominator not equal to 0, and also set the numerator, which is everything under the root, greater or equal to 0. So let's take the first condition, where we have the denominator as x squared minus 4 should not be equal to 0. And then if you take a very good look at this, you understand that what we have here is actually factorizable. So we need to factor our factors from x squared minus 4 is x plus 2 and x minus 2. Should not be equal to 0. So if we separate these factors, we have that x plus 2 should not be equal to 0, and x minus 2 should not be equal to 0 either. So when x should not be equal to negative 2 and x should not be equal to positive 2, that's when you add 2 to both sides here and take out 2 from both sides. Right, so this is the first condition to get the domain of this function. And let's take into consideration the second condition to get the domain of this function. So we'll set everything under this root to be greater or equal to 0. So we have x plus 1 should be greater or equal to 0. Right, so when we subtract 1 from both sides, we have x to be greater or equal to negative 1. Right, so for this, x should be greater or equal to negative 1. Then do not forget the condition from the first one. This is the first condition, this is the second condition, and this third condition. Now we have 3 conditions for the domain of this function. Right, so let's take a good look at all these conditions and see how we can be able to represent them using set notation. We have that x should not be equal to negative 2. Right, and when you remember your number line from the negative infinity going to the positive infinity, you will find that 2 is actually less than negative 1, and this condition already cancels out what we have here, because this condition is telling us that x should be greater or equal to negative 1, which is x should not be as low as negative 2, right? Because negative 2 is actually less than negative 1. So this is out. Right, so because exactly what this is telling us, something something that already supersedes this, right? So that's why we need to take out this. Now we have that x should not be equal to negative 2. So what this means is that x should not be equal to x should not be equal to 2, positive 2, sorry, and the x should be greater or equal to negative 1. So we are going to write this and represent it in set notation, that our domain can be equal to square bracket negative 1. This is telling us that x can actually be equal to negative 1 from this, and up to 2, but not including 2, because x should not be equal to 2. Union everything from 2 without including 2 to positive infinity. So this is the domain of this function. Hope you enjoyed this class. Make sure you share this video to your friends. Make sure you follow and like this video, like our page, also subscribe to our channel. Hope to see you on our next class. Bye for now.